It doesn't know how to make hands right. You know, and so you get these funky hand-looking images and things like that. And this is sort of the most popular version of AI, and sort of the negative sort of connotations about it. Maybe you think it's hype, right? I think a lot of us, especially if you are here, have seen this, that AI is going to 100x your profits and then reduce your work by 1,000%, right? And I think with any new technology, there is always going to be a certain level of hype, and you know, there's going to be buzzwords and overpromises, and you know, things that say it's going to solve everything, and that's not necessarily true. Aspects of this are, you know, maybe for some people, or you know, if you put in enough time, this will happen. But this get rich quick sort of aspect of AI, you know, maybe not. And then, you know, there's also this concept, you know, hype meets reality, where there's these two sort of competing concepts that came out roughly within a month of each other. One was the MIT study that said 95% of all AI projects aren't going to provide an ROI, right? And so that's a very negative aspect, where it's like, okay, well, is AI actually worth it? And then on the other end, you have this ex-Google exec who swears that we're going to be in an AI-driven dystopia by 2027, where no one has a job anymore, essentially, right? So both AI projects fail at an incredibly high rate, but at the same time, none of us are going to have a job. Not sure about those two concepts. How those two work together, you know, I don't totally know. So what is AI really? You know, AI has actually been around for a long time. It is in a huge number of your apps, right? And although it doesn't, I think, seem like AI at times, but you know, like Google Maps, you know, every time you were using Google Maps or Waze or whatever, any of these navigation applications, you were using AI. Grammar assistants was using AI. Dating apps are using AI. The autofocus in your phone is using AI. These are all AI enabled and powered applications. So, you know, let's take things, you know, we're going from sci-fi, you know, killer robots, and then like super hype, to what is it really? Like, what are we really getting from AI? What is this actual concept? And essentially, all AI is based on a neural network. And so the theoretical concept of a neural network came around in 1943 by McCullough and Pitts, and when they theorized the perceptron. And so a perceptron is really a digital neuron, right? And a neuron, right, are the cells in your brain. Like, you have an incredible number of neurons in your brain, and you have even more connections between those neurons, right? And if you've ever heard this, like, I don't know, they explain to you intelligence or learning or whatever, it's like the more connections you have, the more intelligent you are. That's like learning, is connecting the neurons. And so essentially, the way neurons work and the way that the perceptrons work is that you have inputs, and then those inputs get weighted, and then they get summed together by another cell to have an output, right? So if you have X, Y, and Z, and each one of those has a certain weight, and then those all fire, then they go to the next cell, it collects those inputs, and then if it gets to a large enough, what they call action potential, then it will fire and send an output out. Or no, if it hits a certain threshold, then it'll create an action potential. So all neural networks are based on the fundamental principle of neurons and how our brains actually work. These days, you know, when I was back in school, like 25 years ago, there was a huge interest in trying to model the human brain and to do things very similar to the human brain. We don't really do that as much anymore. Generative AI has really strayed away from that. But there's still this basic concept of a neural network and how a neural network works does power essentially all AI. And you know, another way to really kind of understand this from a conceptual level is think about like when you are trying to, say, buy a car or doing any of your decision making. You take in a bunch of different inputs from different, you know, sources, right? So it's like, you know, there's your budget, there's the advice you get from your family and friends, there's ads and reviews you see, there's what's on sale, there's the pushiness of the salesperson, right? And so you have all of these different inputs that are coming in, and then you weigh them differently, right? Like, you know, maybe your budget for you personally is the #1 factor, or maybe you know, you are very susceptible to what a salesperson says, right? Or that newest ad really did catch you, and really it's not usually one thing, it is a collection of things. Like, there are all these little pieces that, you know, sum together, and then boom, you go and you make a decision, you have an output. And that's, again, a very similar way conceptually as to how a neural network works. And then another way to look at this is here's a simple concept of how a neural network would work, right? So like, you could have different inputs, like say, oh, hold on one second. Go away. Thank you. All right, slideshow. Boom. Okay, you could have different inputs. So like, let's say you had this neural network to identify an animal, right? And so the inputs could be like, has fur, like 4 legs, barks, moves, has horns, wings, things like that. And then your outputs would be dog, cat, cow, fish, bird, things like that. And then there would be different weights from your inputs to your outputs. So for example, for a dog, the weight for bark would be really high, right? Because if you had a bark, then that's most likely a dog. Or not most likely a dog, but that's a good indicator that it's a dog, right? Or 4 legs. You know, not as much of an indicator that it's a dog. It could also be a horse or a cow or something, but then that's a higher weight from that input to the output, right? And then same thing with fur. Whereas something like for a fish, fur would have a lower weight. And when we say weight, it's really just like a number that you multiply it by it, right? So let's say a 1 is a very high weight, a 0 is a very low weight, 0.1 is kind of low, a 0.6 is much higher, things like that, right? And so if you wanted to identify all of these different animals and you had all of these different inputs, right, then you would just have these different weights that would be able to tell, oh, if you have these different traits, we're going to weight them this way, these different traits get weighted a different way, and then using that, you would be able to determine whether or not it was one of these animals, right? Then not even usually it is like one of the animals. The way a lot of these neural networks work is that it would give you, there's a highest confidence that it's a certain one of the animals, right? So like, for instance, in something like this, you might have a very high confidence that it's a dog, but then the next one would be like, oh, there's some confidence that it's either a cow or cat as well, something like that, you know, but very low confidence that it's a fish or a bird. And this pattern recognition is essentially how all neural networks work. But then how do we assign these weights? How do we know what the weights are that go from the inputs to the outputs? And this is a concept I came up with once when somebody asked me to explain AI. And essentially what you do is think about it like this. Like, let's say we had a cake making machine, right? And the inputs are the ingredients, and then the nodes are the techniques, and our initial weights are the random guesses at proportions, right? So initially, we have all of these ingredients and we have these techniques like mixing and baking and cooking, but we have a randomized set of proportions, right? So like the first time we try to make a cake, we're like, okay, here, we want to make a chocolate cake, right? The system doesn't know any of the proportions for anything. So it's just like, okay, here, I'll do a cup of sugar, a cup of flour, a cup of salt. We'll cook it for 100 degrees for 10 hours, right? And it's terrible. The first cake is horrible. And you essentially, as being the person who has to taste the cakes, you give the cake making machine the feedback. It's like, no, this was horrible. It's way too salty. It's way too sugary. Probably not too sugary. It's way too salty, right? And it's not cooked well enough. And then you give it that feedback, and then it changes the proportions. You know, it's like, okay, here, let me do less salt, and then I'm going to cook it for a little bit less time, but on a higher temperature. And then it puts out another cake, and it's like, no, this one's not that good either. And then you give it feedback. And this is essentially learning for the cake making machine, but this is how neural networks learn, where they start out and they have, you know, these nodes, they have an input set, they have an output set, but all the weights are very random. And then from there, after going through this system 1,000 times, 1,000,000 times, or whatever, and getting feedback at all times. And there are different systems where they don't do whatever, unsupervised learning, whatever, we can get into that. But essentially at the core, the basic concept of neural networks is this is how it works, right? Is that we have these random weights, in this case, the proportions, the random proportions, and then through learning, you eventually get it better. And then you could think about like that same car decision concept before, right? Where maybe the first time you went to go buy a car, you really paid attention to the commercial, right? And you just had more like weight applied to that initially. But then you bought that first car, and it did not stick to your budget, and then you just had these crazy payments all the time. But you learned from that, right? And so then the next time you changed your weights on a different input, right? Now you put more weight on the input of your budget, right? And again, like this is how all AI works essentially, is by going through this same training process. If you heard, when they were training ChatGPT, it was billions of tokens and text, and then they had to train it to learn these things. This is what it was doing. It was learning these weights, and you would do this again thousands and thousands of times, and eventually you can get not just, and this is really the key to AI. Through this learning, you're not just learning all of the cakes, how to make the cakes that you've already seen. The concept is that what you're able to do is learn how to make a cake that you have never seen before, right? So whereas maybe in our training set for teaching it how to make cakes, we're like, oh, okay, here's like a chocolate cake, here's a vanilla cupcakes, here's a version of a strawberry cake, right? Here is this one. But then oh my God, my phone is blowing up, sorry. But then after you've done the training, theoretically, if you do your cake making machine right, you can then ask it to do chocolate cupcakes, and it would be able to do it even if it had never seen chocolate cupcakes before. But it had seen vanilla cupcakes, and it had seen chocolate cake, and now because it had done that training, it could handle a situation it couldn't handle before. And this is what differentiates AI from, say, automation, right? Where automation, it has very strict rules. It has to be done based on those strict rules, and it can't really deviate from it. With AI, you don't have that same issue, and you can have it handle something that it has never seen before. And this makes it more similar, one of the other, to stay on like sort of the food example. AI is more like a world-class chef, whereas automation is more like a fast food worker, right? Where a fast food worker has a very, they're told this is exactly how much you're supposed to do, just kind of put everything through the assembly line. As a chef can come up with a dish that they just make up on their own, right? And that is sort of the difference between intelligence and automation. But when you are doing your neural networks, there's a couple of things to think about. Size matters. You can't have it be too small, and you can't have it be too large. If it's too small, then it'll never be complex enough to be able to handle your data set. If it's too large, and I've talked about this with you all before, you can have this issue of overfitting. And overfitting is a concept that is very difficult intuitively for a lot of people to understand. Essentially, what it means is that your network memorizes your data set, right? And you know that you're having overfitting when it's starting to handle everything at 100% accuracy. And accuracy sounds good. It only sounds good for an automation system. It does not work well for a neural network for an AI system, because at 100%, it means, again, that it has memorized your data set, and then now in the future it won't be able to make the chocolate cupcakes. It would only be able to make chocolate cake or the vanilla cupcakes because it was trained on those, and that's not what you want. You want this new cake making machine that can make any cake in the world, that it could make this Batman cake if you wanted to, right? And so you have to avoid overfitting, and you really want to be in the Goldilocks zone where you have a neural network that is the right size, not too small, not too big. And also the same thing, it's trained for the right amount of time, not trained for too low, not trained for too high, or too much amount of time. Bias. So bias is an issue here. And to stay on this cake making example, if when you're training your cake making machine, you only saw vanilla cakes, guess what it'll default to? If you ask it to make a cake, it will just be making vanilla cakes, right? And obviously that's a very simplistic version of this, but this is an issue that we have with our AI and our neural networks, and you can see it in all kinds of different things. You possibly have noticed some of this stuff in ChatGPT if you're using it. One of the things that you can really see in open source image generators is they are biased to different racial compositions, right? So they have a bias towards white European people and to Asian people. It's just one of the things. If you just ask it to create a person, it will most likely create a person within those racial compositions. And then there are other things where it's like, we are only training the AI on our data, and we are biased ourselves. And so there have been, stories in the news where there was this company that was like doing a job board, and they were sending all the higher paying, not all of, but more of the higher paying jobs to men than to women, because historically men made more money than women, right? And so because we have this bias in our world, sometimes we are biasing our AI. And then other times it's just choosing a bad data set, right? Like part of what you want to do when you're trying to create the best data set is making sure that it is robust and diverse so that you get a much better AI system. So why is AI exploding right now? We've had machine learning and computer vision and natural language processing. These have been around for a while. As I said, these things were in your phone. We've been using them for Google Maps, but now AI seems like it's everywhere. Everyone's talking about it. So why is that happening? Part of it is that hardware finally caught up, right? So most modern AI, especially like generative AI, is being run on video cards. I've talked about this a lot. GPUs, right? And so initially GPUs were being developed for visual effects and for video game users, so that they could have faster, they'd be able to have faster video game loading for professional gamers, things like that. And then if you think of things like Avatar, right, where they had these huge 3D immersive worlds that had to be created, they needed really big GPUs for that. But then they realized that actually these GPUs were great for running AI models on, and this is why NVIDIA stock is so high. And so we now have bigger and bigger GPUs where we can run and train much larger models. We do have new model types, right? So the transformers made large language models, LLMs, which power ChatGPT. They became popular, or they were developed in 2017, right? So it's only seven. That's when they were conceptualized, right? This transformer system, right? And then latent diffusion came around in 2021, right? And that's what's powering most image generators, right? And so these actual new model types were recently just invented. So even though we've had AI for a long time, these new models just came about. So the neural networks themselves, the AI that we've been using, some of the more typical AI has been around for a while, but these new models, they're pretty new as far as technology goes. And we're just scratching the surface on being able to use these new models. And then pre-trained models. So as I already mentioned, it takes years, billions of examples to train these bigger models. Some of the smaller models that you can actually train yourself, if you're interested, don't take that much. But something like ChatGPT, right? You probably read about this. I think they said it was hundreds of millions of dollars to train that, and so that took years. It took a lot of training. Now it's done. Now we are trained. We're just at that point right now, right, where they first developed the concept of these models. Then we have the GPUs, we've trained the models, and now we're here. Now the generative AI is here. And then finally, ChatGPT. ChatGPT changed everything. Again, there's all these other pieces that matter and that contributed to AI. These are the shoulders that everything is standing on. But without a doubt, and even there are competitors. There's Claude, Perplexity, Gemini, Grok, Llama, Mistral, DeepSeek. ChatGPT was, the fastest platform to get 100 million users on it. It is a phenomenon. It is a huge deal, and this is the thing that is not just putting AI on the map in a very real way, but then also, a lot of applications are using the OpenAI API to be able to power their functionality, right? Where they're creating their apps and they're using that technology to do it. Okay, so then there are really 4 different types of AI. I mean, you could probably break it down into all kinds of other types. We'll start off with machine learning. Machine learning is the simplest kind. Machine learning is also this term that I think gets, what did I say, confused or is very difficult. Sometimes everything is machine learning, sometimes nothing is machine learning. I like to look at it as like classic form of AI. It works on data and numbers, statistics, spreadsheets, things like that. You use decision trees and LSTMs, long short-term memory networks to find patterns. And this is very, to me, very numerical based. People use machine learning for stocks and sale forecasts, to model audience behavior, to do predictive things, analyzing sports outcomes, things like that. So that's machine learning. Then we have computer vision. Computer vision is one of my favorite. So essentially this allows AI to see. At its core, all neural networks only work on numbers, but with computer vision, essentially what we do is we translate those images into numbers, or that video. Video is just a sequence of images that gets translated into numbers, and then we use typically what's called a CNN, a convolutional neural network, to be able to do computer vision tasks. And so these are things like object detection, which can be used for quality control in factories or self-driving cars. Motion tracking, you can see a lot of this in sort of sports analysis or even security cameras. Facial recognition, right? I think at this point, a lot of us have used facial recognition for something. And then OCR, one of my favorite, is basically able to take a picture of a document and then extract the text out of it so that now you have searchable digital text. OCR is, again, one of these just these little sort of hidden AI technologies that is going to and is sort of changing the world. So computer vision basically allows AI to see, and it does a lot of the work that humans are able to do with their eyeballs and their visual cortex. And we have natural language processing. So again, like all AI works on numbers, but then what we do is we transform the language, the words, into numbers, and then it finds patterns within those numbers and those tokenized numbers. And this works for things like grammar tools, which I already brought up, translation services, so like Google Translate, text summarization, OCR, right? So some of this stuff has overlap, right? So like OCR is both kind of natural language processing and computer vision, for a variety of reasons. And then they on one end, like there'll be more computer vision that goes into the OCR, and then on the other end, there'll be a little bit more NLP on the other side. And then very advanced applications, so large language models. So these are very large models that deal with language, right? So that is ChatGPT and Claude and all those other platforms. They have large language models powering them. That is a form of NLP. Text to speech and speech to text. So like Alexa and Siri, right? We've had those for a long time. Those are all NLP systems that allow basically AI to understand text, right? And this allows us to have more sort of natural language interactions with AI. And then finally, we have generative AI. So this is the big one. Look at this guy, made with GenSpark. Where'd that come from? I gotta figure out how to get rid of that. It's weird that it just threw that in the middle of this one slide, right? So this is the newest, this is the flashiest one. This is the one that powers ChatGPT, right? This is the one that makes it so that we can have image and video generation. It's called generative because it actually generates something. Where if you look at the other AI up until here, essentially it was more analytical. It would just analyze data or find patterns, whereas this one's actually creating something, right? It's creating images and videos and text, and it is the part that has really made people go wow. And it is also the aspect that is the most what would you say, the most resource intensive. So if you look at Gen AI models, they're huge, typically, on the order of gigabytes instead of megabytes. And they take, this is part of the reason why we need those GPUs, is to power these generative models and all of the processing power that they require. Okay, so some of the things that go into AI that really matter and are a big deal. So data prep. AI isn't really just all about writing code, but it is about having data. Like as we talked about at the top, like you need data to be able to train these systems. You need to make sure that we don't have bias issue, missing data. So one of the major things that we have to do is find clean up data when we get it. A lot of times it is missing data and it's just hasn't been collected well. And then improper formatting and not just that, it's like, a lot of data needs to be labeled, right? Like you could have data, but like we need to be able to label it when we're training, right? Like when I gave that example before, for like say like the dog, the cat sort of example, when that neural network was learning, it needed to know that fur and four legs and bark was dog. Like we all know that, but it didn't know that. So it would need to have that input data with those pieces labeled with the output data, so that once it goes through the system and it either gets it right or wrong, you're able to tell the system, oh, you're right or you're wrong, change your weights depending on that, right? And so properly labeled data is a big deal. And this is one of the biggest issues that like holds back companies from bringing in AI or adopting AI. And it's not even just the training of new models, but also testing new solutions, right? How do you test out your new AI solution if you don't have properly labeled data to know, how the testing is supposed to go? Another thing to think about is pre-trained open source models. Again, if you're here on Tuesday, I just did a whole class on, or a whole call on this, but I think a lot of people got introduced to AI through ChatGPT, and that's a platform that you pay for, or it's a freemium platform. A lot of these AI platforms are freemium or per pay. But really, AI is a very open source field, and a lot of this stuff is developed by researchers at universities and colleges. And a place like Hugging Face or even Civet AI, ooh, I gotta put in the extra IVIT on there, they host free models. And really, if you wanted to, you could build any AI application really in the world and use these free AI models. A lot of times they are MIT licensed or even Apache license, which allows you to use them without paying anybody. You will potentially need to pay for the computing service to run these models. But if you want, to start up and build your own AI application, all the models in the world are just out there. They're there for you to use. And then even the ones you have to pay API services for, those are fairly inexpensive, again, to get them off the ground. But once you get to scale, hopefully you're making money off of them, and then it makes some sort of business sense. And then cloud computing. So again, like all of this stuff is really being run on the cloud. Not all of it totally, but like cloud computing is a big deal. Again, this is part of the reason why NVIDIA stock is so high, is that they're building these huge AI data centers using GPUs. There are different cloud providers, RunPod, Google Cloud, AWS, Azure. A huge amount of AI is being done through these platforms. If you're trying to build an enterprise solution or you're trying to leverage these big GPUs, again, you don't need to buy them. Like some of these GPUs cost $40. Like that maybe is prohibitive. However, you can rent them through a cloud computing service. And then also by renting them through these cloud computing services, then you now make your AI application available to people all over the world. And then prompt engineering. So, coding is, at least, traditional coding, the way that people have always done it, is sort of on the way out. You still need to understand code from a technical perspective and an architectural perspective. And then there's more to coding than just coding up a program. Again, you have to put it into a cloud environment, Dockerize it, do all kinds of different things. However, one of the biggest sort of most growing skills is prompt engineering and being able to use prompting to help you code, right? But then also prompt engineering is kind of able to give you the ability to create agents. And if you've heard, we're going to talk a little bit more about agents, but being able to create prompts for these agents to then be able to execute operations from there. And so, whereas we are going to see a sort of down trend with people coding in a traditional coding type of way, we're going to see an uptrend in people prompting and prompt engineering. Oops, going backwards. All right, so here are a few different very sort of popular ways of using AI now, especially generative AI. So there's RAG, so retrieval augmented generation. So LLMs, these large language models that power ChatGPT, Claude, platforms like that, they have issues to them. One is that they hallucinate. If you probably heard this term before, that they just make things up. And then they have a limited context window, which means that they can only do certain things. You can only, if you've noticed, like sometimes you can only upload a certain size of a document to them. And it doesn't know everything. It's only trained on a snapshot of like typically the internet at a time. But RAG gives you this ability to essentially give a large language model access to a knowledge base. And by having access to that knowledge base, it's able to look up different pieces of information that it can then infuse into its prompt and then answer questions based on that. So then this gives you the ability to do things like create a chat bot for your company to do customer service that actually knows about your company and about your services. It also allows you to do auto-generated reports, and you could generate reports of any size, and you can input a huge knowledge base into it to generate a report. And you can also use it to do a document Q&A system where if you have like these 500-page contracts, then you could put them into a RAG system and then just be able to naturally ask questions of it, things like that. Graph RAG. So Graph RAG is a more complex version of RAG. I want to work on this Graph RAG graphic. It's not that great. That's the one that came out of GenSpark. But essentially, RAG just grabs you different pieces of information and then takes that information and just gives it over to the LLM system. And they call this flat because it's just, say, 3 to 5 discrete pieces of information here. Take these pieces of information and then throw them into the LLM and have it respond based on these pieces of information. Graph RAG, instead of just having these discrete pieces of knowledge, it actually connects them together with logical connections. So if you see here, you could take these different pieces, Paris, France, EU, and trade, and connect them together in a graph. And then instead of just having individual pieces, now your knowledge base is connected together conceptually, and it makes your system, your RAG system, even more intelligent. Agents and agentic workflows. And so like each one of these are like the big buzziest terms in AI at a various point in time. And the agent thing has been going very strong, which is basically taking an LLM and having it be, not just processing information and text, but making decisions and then giving it access to tools when it's making those decisions, right? And so then you can do things like have it do lead generation, have it do scheduling and calendar automation, having it handle operations. It can be a research assistant. When you use ChatGPT, Claude, Perplexity, Gemini, Grok, any of these things, they are not just LLMs, they are actually highly agentic interfaces with an LLM behind it. And one of the things you'll find is if you do connect to their API access for their LLMs, it is way less useful than when you actually use it in their interface because of the agentic nature of their platforms. And you can see this sometimes if you ever see what it's doing in the background and see the logic that it's going through. You can see that it's going through all these different steps and figuring all these different things out. That is the agentic aspect of this and how an agentic workflow works. And then MCP is pretty cool. So this is the next level of agenticness or of agentic system. And really the bottom line here is that with an MCP, so it's a model context protocol, it was very buzzy. It was all over the place earlier this year. If you were following AI LinkedIn, essentially, then you just saw MCP servers all over the place earlier this year. And really just the bottom line with it and how it works is basically it allows you to connect an LLM, so like Claude or GPT or whatever you want, to your software, to your actual software. So like in this case, instead of just giving it some like basic tools that you would code up, now it can control things like QuickBooks or other software on your computer. They have to be the MCP servers or the MCP needs to be set up and able to interact with those software platforms. But once they are, then now you can directly connect an LLM system to your actual software, which is pretty cool. All right, so let me see. Ooh. All right, I'm gonna have to figure out a way to shave this presentation down. One thing to think about is you want to get the right balance between the human and AI. So this is always coming up, is the job loss debate between, is AI going to take our jobs, things like that. And one thing that I tell people is that AI won't take your job, but somebody using AI will. And really, we need to think about not just having AI take over and do everything. You really want to do what they call human in the loop, where AI is really good at repetitive tasks, at very simple tasks, but at higher level decision making, it's just not there yet. And so by maintaining human in the loop along with AI automation power, you can get pretty far. And one of the things you really want to also make sure of, when part of the reason why you want to have human in the loop is accountability. If something goes wrong, you really can't just blame the AI, right? There is going to be a person who's going to have to be blamed, and so they need to be in the loop so that they are not just blindly allowing AI to do whatever it wants. If you really think about upskilling your workforce, AI isn't optional anymore. Most employees have never been trained or evaluated a model. Most leaders don't fully understand AI. You need to provide training for your workers, be able to build or have someone build custom models for your business, and then really be able to educate decision makers on realistic capabilities and risks. Part of the problem that you can run into is allowing AI to make decisions without oversight, blindly trusting outputs without fact checking, or having fuzzy or missing goals for your AI development. So if you saw that 95% failure rate from MIT, this is part of the reason why, is because people are running into issues like this. And data privacy. This is a big deal for if you are running your own open source models on your own server. This is not as big of an issue. But if a lot of these AI platforms, you are sending your data via API to a AI model, and potentially it can be used to train those AI models. If you have HIPAA, COPA, CPVA, any of these other regulatory rules over your data, you need to have a solution for that. There are solutions out there, but you do need to just think about them and utilize them. I think that a lot of times companies use these as roadblocks to not move forward, when really they are just things to consider when moving forward. And then legal considerations. So nobody knows. It is currently the wild, wild west. For the most part, when there are issues with copyright, as far as like the material that was used was copywritten, and then that was used to train the AI models. Typically, it is the company that was doing it where that burden comes down on, right? So like people are suing OpenAI, they're suing Anthropic, things like that. They're not suing the end user who used those models. So for you, that's who you are, right? You're the end user who's using those models. You don't really have to worry as much as those companies need to worry. And my prediction is that they are going to eventually go to a more YouTube-like style arrangement for the data. If you saw how YouTube at one point in time was seen as this big risk because of all of the copywritten material that was on there, how are they going to deal with it? Google figured out a way, and now YouTube is a gigantic, like one of the biggest, what did you say, media companies in the entire world, the biggest, right? And that's probably where AI is going, where they are going to have to start to figure out how to handle this copywritten material. But you should stay cautious. And if you're generating material with AI, they're saying right now is that you need to make it somewhat, you have to transform that AI material. You have to have some sort of human intervention on it, although that is a very gray area. And there isn't really a lot of work that's being done now where people are trying to copyright it, the material that they're doing with AI. But then at the same time, I think they just funded a $30 million AI generated movie. So this stuff is coming. Your company should be laying the groundwork for an AI policy. You do need to define your AI goals, your scope, and your roadmap. Should be educating your employees, really setting usage guidelines to avoid errors, like essentially don't let people copy and paste. And then you do need to establish policies for data privacy, security, and copyright. And then for governance and action, you want to assign decision makers and accountability. Again, somebody needs to be accountable for this AI. You really need to be tracking and reviewing your AI progress and performance regularly. And then align with your legal, regulatory, and ethical standards. Like these things really matter, especially with AI and where everything is going. And then a huge amount of communication. People really need to understand not exactly how, say, a neural network works at its core, but really how does this AI work and what is it doing for you? And so then finally, how am I doing? All right, I gotta probably shave 5 minutes off this thing. Is AI still worth it? Yes. Well, new major innovations require rules, and AI is no different than any other technology, but probably more powerful, right? It has with structure, the benefits are transformative, right? That's why a lot of us are here. And then this is something that I've brought up before. If we stop making models, which we're not going to, they just, Sora 2 just came out, GPT-5 just came out, Sonnet 4.5 just came out. They're planning on making more and more models and advancing them. But if they didn't, there is still tens to hundreds of trillions of dollars of opportunity in AI adoption. There is in so much we have not adopted AI to be used in our workplace, and not to replace people, but to make people's jobs easier, essentially. It is going to take effort and strategic thinking. You need that HI, that human intelligence, as much as you need that AI, right? But if you're done right, your AI will set your company apart, and you can be part of that 5% that's successful and not the 95% that isn't. And I'm here to help you for your to make your AI journey successful. Boom. Definitely talked fast during that one. Okay, any questions for anything? I know that was a lot to take in all at once. Yeah, I'm sure you, Ernest, you probably heard almost all of that before at some point in time.
So Jeff, this is overall, right? Like it's everything what we can do through AI, right? Whatever the view which you.
Yeah, I mean, there's obviously more that you can do with AI, but the idea is that this is supposed to give you an overall view of AI from, even the neural network model, from like the larger perspective to, really where are we now with it. And then, yeah, I mean, when you look at something like machine learning, NLP, computer vision, and generative AI, like that is all the major AI things. But then there are things that aren't in there, like reinforcement learning or unsupervised learning. There's all kinds of other pieces that you can go into. I am trying to condense down like probably a year's worth of AI education into an hour, essentially.
Yeah. No. What I mean here is, at least at high level, this touches those points, right? Deeper, you can
Yeah.
go into the subjects, but I'm just wondering, like this covers overall. If anybody wants to go deeper into, then they can further dig into. Okay.
All right. And I think, yeah, this does definitely give you an overview and touches on all the different aspects that you should be thinking about, right? Like things like bias or, data privacy, or, you're going to need a cloud computing service, or hey, like, what are you doing about, what kind of GPUs do you need to run your models, things like that.
But I'm just wondering, this is all like from the back end. Like, do we have now this vibe coding and context engineering? Those all bits are separate topics, right? Or those will be. I know this is like, okay, we have Hugging Face, other things like, but yeah.
What was your question, I guess?
So my question was, those topics are separate, like vibe coding is there, context engineering is there.
Well, I mean, vibe coding was sort of thrown in there in the prompt engineering and the prompting system, right? Like if you are using prompting to do coding, then that is vibe coding. That might be something I should just throw in that terminology in there. But that is sort of that idea of going from, not coding in a traditional way and instead using prompting to help you code. That's vibe coding, right?
But now they're different context. They're saying vibe coding with context gives more accuracy. It will automatically brand your things, everything. You need to give the context instead of prompting. So it is evolving, right? Because in the code, if you see 80-70% are like means from the development coder, so that's a very big chunk of IT, right? So
I think that it's really, with vibe coding, it's one of those things where maybe it's like a really fast car or something like that. If you have somebody who's really good at driving, then they will be able to get from point A to point B much better. They'll be able to get there faster. If you have somebody who's terrible at driving and you give them a Ferrari that can go 200 miles an hour, they're going to crash it. And I think for some of us, but then also, if you're doing it in a simulated sort of video game, right, where it's like, well, okay, you're allowed to crash the Ferrari a bunch of times, it's okay, and then eventually you get better at driving. That's, again, because for some of us who are on here who started off just vibe coding with projects, or even, for some projects I do now, like I would not have been able to do it without vibe coding. Like I just didn't understand the system, and so it gives me the ability to stretch myself out. But if you're not used to, again, like things like Dockerization, right, or how to set up a good roadmap for your project, then you're going to crash because now you have this $200,000 car that can go way too fast.
Okay. Yeah. Nice answer. Yeah, thanks.
And then really quick, sorry, time to go. But so that presentation I did with GenSpark, the one that I did with Gamma, maybe next week at the beginning for Q&A, I will go over what things look like in GenSpark, what things look like in Gamma, how much I had to change it. Because again, like neither one of them were going to produce a presentation that looked like that. There are even some errors in that I could pick up. I still haven't filled it out better, but that looks 50% better than what GenSpark produced. But again, I would suggest using something like Gamma or GenSpark just to get you, 60, 70% of the way, and then you just have to do the rest yourself. And the same type of thing, I would not have made something that looked probably as good as this is going to look if I didn't use one of those platforms. But okay, 101, at least my time. Thank you, everybody.